Hello, good day. I am Leonardo B. Castromero Jr. I am going to present our research entitled Coir as a proposed alternative composite material for synthetic fiber. Background of the study. Composite has been one of the most material that is being used in our modern technology. It has a rich history which dated back 1,000 years with the Egyptians and Mesopotamian. With the growth of our modern technology, composite has been integrated in the aviation industry, thus making flying in the air safe, efficient, and profitable. Since there is an abundant supply of coir in our country, coir fiber will be used as a raw material for doing a composite material. Using this kind of natural fiber, coir in reinforced composite can reduce not only the conventional concrete making material but also environmental impacts. Coir is a natural fiber of coconut husk where it is thick and coarse but durable fiber. It is relatively waterproof and has resistant to damage by saltwater and microbial degradation. The strength of coir fiber reinforced composite tends to decrease with the amount of fiber, which indicated ineffective stress transfer between the fiber and matrix. The introduction. Composite is material produced using at least two unique materials that, when combined, are stronger than those individual materials by themselves, or we can simply say that composites are a combination of components. Another type of composite is the biocomposite, which is the eco-friendly one. This type of composite consists of a large variety of organic and or inorganic components, such as natural polymers. Natural fibers are widely used under the biocomposite. It is reinforcing fibers that are derived from renewable and carbon dioxide neutral resources such as wood or plants. Coconut fiber is extracted from the outer shell of a coconut. Coconut fiber are stiff and tough and have low thermal conductivity. This part of the coconut serve as an asset for natural fibers, which are used to support polymer composites. Coir fibers are strong and stiff, which are prerequisites for coir fiber reinforced biocomposite materials. Statement of the problem. The following questions below are to be answered in the study about coir as a proposed alternative composite material for synthetic fiber. Number 1. What is the composite material's strength to weight ratio? Number 2. How well is the composite going to perform under impact loads? Number 3. What are the differences with coir fiber composite compared to a fiberglass? Number 4. How does coir fiber perform as an alternative composite material? Related literature. According to Majid Ali and others, he investigated and studied the versatility and application of coconut fiber in different kinds. He concluded that coconut fiber are reported as more ductile and energy absorbent material. It is concluded that coconut fiber have potential to be used in composite for different purposes. Natural fibers are environment-friendly materials and have proved to be a competitive for glass fiber or polyester in terms of strength, performance, and cost, according to Bayarda and others. Combination of natural fiber reinforced polyester composites has been demonstrated to be an effective method to design materials suited for various requirements. Earlier studies by Brahmakumar and others proved that the core fibers can be used as effective reinforcement and bonded in polyester matrix. Research gap. Many studies have not tackled the use of machinery in preparing the coir fiber. They only use the fiber that is already extracted from the coconut, and they have not manually or by use of machine removed the coir one by one. Because of the characteristics of the coir fiber, it is very difficult to use it as a reinforcing material. So one of the suggestions is to weave it like a cotton or a cloth or like the standard glass fiber. Conceptual framework. The diagram shows the steps and procedures that will be conducted for the completion of the study. The first step is preparing all the materials needed in making the composite materials such as polyester resin, hardener, coir fiber, brush, tapes, and sandpaper. The researchers will make a sample molder to precisely mold the composite material and will be cured with plenty amount of time. After that, mix the proper ratio of polyester resin and hardener. Mix it well. Then first, the application of first layer of polyester resin to the mold using a brush. Second, place the coir fiber reinforcing material on the matrix. Third, apply resin on the top of the first layer of reinforcing material. Repeat the second and third step until there are 3 layers of reinforcing material. Key the entire surface again for the next coat of resin to be able for the next layer to attach stronger and let it cure. After that, Flatten the surface using fine sandpaper, then apply the final layer of resin. Then, let it cure for 12 hours. Once the material is cured, remove the composite from the molder. Research paradigm or conceptual framework. First is prepare all the materials needed, make a sample molder, mix the polyester resin and hardener. Apply the first layer of polyester resin to the molder. Next is place the first layer of reinforcing material. Then apply the second layer of the polyester resin. Then place the second layer of reinforcing material. Then apply the third layer of polyester resin. Next is to place the third layer of reinforcing material. Then apply the fourth polyester resin. Then let it cure for several hours. Next is to flatten the surface using fine sandpaper. Then apply the final layer of polyester resin. Then let it cure for 12 hours. Once cured, remove the composite from the molder. Research methodology. The researchers created a research title and presented to the advisor for approval and to give feedback to said title. After approval of the title, the researchers started to conduct a search for related topics and information using the various resources such as online journals, internet, books, published and unpublished theses. This study focused on the manufacturing of fiberglass reinforcing materials and alternative core fiber reinforcing material. After the manufacturing has been done, the built molded fiberglass and core fiber will undergo several testings and checking, and this stage will help the researchers to build up conclusions. A statistical treatment, strength to weight ratio. This will be used to determine the correlation of the material's weight with its strength. Strength to weight ratio is equal to strength times weight over mass. Kinetic energy. This will be used to accurately calculate the kinetic energy that will be applied to the composite materials during impact testing. Kinetic energy is equals to 1/2 mv squared. Velocity is equals to time times acceleration. Statement of the problem. Statement of the problem number 1. What is the composite material strength to weight ratio? Finding. The descriptive static shows that core fiber from sample 1 to 4 has an average strength to weight ratio of 36.11, while its counterpart has an average strength to weight ratio of 52.31. Conclusion. The researchers concluded that increasing the number of light to the core is directly proportional to its weight and strength. Therefore, aiming to provide good strength, a high amount of materials is needed. Recommendation. The core should be dense enough for it to have the same strength as the standard glass fiber, but the weight should be also optimal so that it can be used in aviation. Statement of the problem number 2. How well is the composite going to perform under impact loads? Findings. Based on the result, the core fiber impact to the load nearly reached the impact test results of the fiberglass. The core impact results are nearly the same compared to fiberglass results, which may denote that core fiber can also handle the impact load that the sample with fiberglass can. Conclusion. Based on the impact test, the two types of material, which is the core and fiberglass, the core had a minimal visible crack while the fiberglass was neat and durable. Since the fiberglass are the basis of this study, the researchers conducted the test to ensure the amount needed for the core to be able to replace as synthetic fiberglass composite material. Recommendation. Actual impact test should be done with the use of advanced technology to accurately gauge the result properly. Different impact test techniques should be applied so that you can accurately compute the result and differentiate the difference between the alternative and standard reinforcing material. Statement of the problem number 3. What are the differences with core fiber composite compared to a glass fiber? Finding. There were clear differences between the two when both are studied. The core fiber from sample 1 to 4 has an average strength of 7,537 grams, while the fiberglass from sample 1 to 4 has an average strength of 9,912 grams. Based on the results, fiberglass have much strength compared to core fiber. A small amount of weight can cause large amount of strength for fiberglass, while in core fiber, it need more weight to have greater strength. More amount of core fiber is needed to be able to compare its strength to fiberglass. Conclusion. In terms of strength, fiberglass is better than the core. Since the researchers' goal is to provide an alternative for fiberglass, which is the core, several testing was done and proved that huge amount of core will provide strength needed for the better quality of fiberglass. Recommendation: to further develop the core fiber composite mixture in order to create an optimal strength compared to a fiberglass. Statement of the problem number 4. How does core fiber perform as an alternative composite material? Findings. As an alternative composite material, the core fiber can be the best one due to its strength capacity. Since core is readily available in the Philippines, the need of greater amount of core is not a problem. To ensure that the core can be best replacement, it needs to overcome the load impact capacity of fiberglass. With that, adding greater amount of core will provide better results. Conclusion. Therefore, the researchers conclude, based from the series of tests, that the core fiber has the potential to be used in composite. Recommendation: it can serve as a reference for future studies in core fiber as an alternative application in different industries. Here is a video clip of our experiment. This is our first trial. We've made a mold using styrofoam and duct tapes. Then we put the core fiber on it. After that, you can see in the picture that we are putting our mixture on the core fiber. After several hours, the mixture leaked on our mold, so this was a failed experiment. And then we made another mold using tiles and duct tapes. And this is how it looked like. And then we've put our coir fiber and put some mixture on it. And then we made our composite using a fiberglass as a reinforcing material for comparison. And this is how it looks like when we are curing it. And this is how our core fiber looks like when we have keyed it already using fine sandpapers. This is the side view of the material. This is what it looked like when we have sanded it using grinders. And these are all our samples. And these are the samples for the fiberglass. And that's all. Thank you for listening. Have a good day.